Hello student, last lecture we discussed about the topic application of logarithmic function. We take some example so you get the idea about the application of logarithmic function. Logarithmic function most probably used in a chemistry subject for what? I explain the objectives. Write equivalent form for exponential and logarithmic function. Write, evaluate and graph logarithmic function. Vocabulary, logarithm, common logarithm, logarithmic function. Why are we learning this? A logarithmic scale is used to measure the acidity or pH or of water or juices of any liquid form of the thing. In a chemistry lecture, you study the detail about the logarithmic function is used and how to calculate the acidity or pH value of water or any juices. Today's lecture, we define there are inverse function of each other. What means that? Exponential function, I derive the values in a form of general form y is equal to f of x is equal to a raised to x. Passes through 0, 1. That means the starting value is 0 and ending value is 1. That is called the x value is always the domain and it is the real number. Range y is always a range and is always all positive. Now discuss about logarithmic function. Y is equal to f of x. We should write log x to the base a. Our exponential function is a raised to x. That goes to a goes to base x is equal to y. Suppose passes through 1, 0. 1 is real number and 0 is a prime number. That gives the statement domain x is always positive. That is the value of x start with 1. Log of 1 is 0 and we go to up to 0. That's why range y is all real numbers, any types of real numbers. For discuss the different types of example in a chapter logarithm, we must know the basic exponential laws. That are what? First is x raised to a into x raised to b. X is variable, a and b are numbers, is equal to x raised to a plus b. That means if base is same, then index goes to plus sign is there because multiplication symbol is there. Go to these properties or laws. We discuss first these one. X raised to minus a is equal to 1 upon x raised to a. That means this a goes to numerator, get the value negative. So now we discuss the second property that is useful here. X raised to a upon x raised to b. I convert this into, it goes to x into a into x raised to minus b by using this law. So I have the x raised to a into x raised to minus b. But base is same, the index number is add or subtract because minus is there, so that's why we can write x raised to a minus b. Now x raised to a bracket raised to b is there, is equal to x raised to a into b. That means what? X raised to any number and bracket raised to any number goes to multiplication symbol is there, that is x raised to a into b is there. Just we discuss about x raised to minus a is equal to 1 upon x raised to a. That means negative sign in a denominator goes of index will be positive. And if positive is there, goes to numerator will be negative. X raised to 0 is equal to 1. Any number x raised to 0 is always 1. We should discuss these all law of indices in a 10th standard. So I take revision of these things. Logarithm laws, these are useful in our next example and exercise example. That are what? Very simple are there. Log in bracket a into b is equal to log a plus log b. That means if both numbers are there and multiplication is there and log is outside the bracket, then we can distribute always log A plus log B. Log A upon B means what? Log A minus log B. That is, division is there, then we should write minus sign is there, that is log A minus log B. Third one, log A raised to B. These number in this called the power law of logarithm laws. That means what? Any number raised to other number, this number goes to this side of the logarithm, that is left hand side of logarithm, and this number A remain as the same. For any base we can apply. Next one, they give the first one is log 1 to the base x is 0. Then I discuss this property. What are they? Log to the base x 1 upon x raised to a is equal to minus a. This is the application of all the power function and this one function. Log. How we derive? We know 1 upon x raised to minus a is what? X raised to minus a. So this goes to this numerator. Then minus symbol goes to this side by using power function. Log x to the base x is always 1. So that's why we derive the answer is minus a. That means the base of the log and 1 upon x raised to a, these both numbers must be equal. Then we directly write the index of that number with negative sign. So we discussed that exponential function is always in a form of a raised to x. But my question is there, f of x equal to 0 raised to x, I put the value of a is 0. Second function I put the value of a is 1. And in third function I put the value of a is minus 2. But are not an exponential function. Why? Think about that statement. I will give 5 seconds. Okay student, first you check that I put the value of a here. But if I put the value of x, starting value is obviously 0. Natural numbers start from the 0. I put 0 raised to 0, 0, 0 raised to 1, 0, 0 raised to 2 is always 0. That means this function is not in a fixed form. That's why it is not exponential. Second, g of x equal to 1 raised to x. I put suppose 1 raised to 1, 1, 1 raised to 2, 1. That means it remains as the same. But if I put x equal to 1, I derive first value is minus 2 raised to 1 minus 2. If I put x equal to 2, I derive minus 2 raised to 2. Minus 2 into minus 2 always 4. So I not get the positive values. That's why these functions are not always the exponential function. In this throughout chapter, we must need some properties of exponent. Just we discussed, but I will give the example of this function. How we derive? That's why I give that let a and b real numbers and let m and n are integer. Real numbers, these include all the sets, and m and integer, that means be positive, negative, depend on that value. For example, first product of powers. A raised to m into a raised to n is always a raised to m plus n. So I get, suppose I put the value of a is 3 and value of m is 2 and value of n is equal to 5. So I derive 3 raised to 2 plus 5 by this product of power, that is properties of exponent. Power of power means what? A raised to m bracket raised to n is equal to a raised to mn. That is 2 raised to 3 bracket raised to 2 is always 2 raised to 3 into 2. You should write 2 raised to 6 also. Power of product. If a raised to b raised to m is there, so we should write a raised to m into b raised to m. That means what? 4 and 3 are different number, but power is same. Then that is 3. So I can distribute both the numbers have the same index, that is 4 raised to 3 into 3 raised to 3. Negative exponent. A raised to minus m is equal to 1 upon a raised to m. A not equal to 0. So I put a is equal to 5. M is 2. So 5 raised to minus 2 is always 1 upon 5 square. you should write 1 upon 25 because the 5 square is 25. Now 0 exponent is there. Always remind that any number raised to 0 is always 1. That means I put the a is equal to 100. 100 raised to 0 is equal to 1. Any digit number you can apply, it remain as the same. A raised to, that is the important law, quotient of the power. A raised to m upon a raised to n is equal to a raised to m minus n, a not equal to 0. That means I put the value of a is 3, m value is 5 and n value is 2. So we should shift 2 in the minus form, that is we have to use this negative exponent power law. And we discussed 3 raised to 5 minus 2, obviously 3 raised to 3. We derive the answer is simplification is 3 raised to 3 is always 27. Power of quotient, that is a upon b raised to m, that is a raised to m upon b raised to m. Always remind that b not equal to 0. That means what? 3 upon 5 raised to 4 is always 3 raised to 4 upon 5 raised to 4. Be particular student about these properties of exponent. In an up to standard, you study about the law of indices. You always remind that product of power, that is base are same, then index goes to plus. Power of power means any number raised to bracket raised to different number, that index goes to multiplication. Power of product, that is the two numbers have the multiplication, that is product is between there and index is same, then we can distribute each number with the same index, that is a raised to m into b raised to m. Negative exponent is a raised to minus m is equal to 1 upon a raised to m. That means if we have to take the negative numbers in an index, that we can write 1 upon that a raised to, but index is positive. 0 exponent is a raised to 0 is equal to 1 and a not equal to 0, that is any number raised to 0 is always 1. Quotient of power, that is a raised to m upon a raised to n is a raised to m minus n. That means any numbers, same number is numerator and denominator but different index are there, then we should write a raised to denominator numbers index will be negative by using first this property of negative exponent most probably and simplify. Power of quotient is always a upon b, that is the quotient you know, and the index is same, then we can distribute a raised to m upon b raised to m, but remind that any denominator number b not equal to 0. It is the this column we have to must know log a to the base a is always 1, log of 1 is equal to 0, that is log m into n is equal to log m upon n a plus log n upon to the base a.